Morning. My name is Mani Ganesan. I run product management team for Prosimo. I'm joined here by my esteemed colleagues. So I'm going to kick off the presentation here with an intro, set the table here on what exactly are the challenges faced by the enterprises, what is kind of driving the market for the need for a multi-cloud networking. And then this time around, we're not going to go deeper into what are the components of the solution, how we make it work. We did all of that last year. This time around, it's all going to be around customer journey. We're going to take a real life customer topology and start with what are the challenges they faced, kind of step by step. And our demos are all going to be around what was the challenge, how did they fix it, and then from start to the end. So that's going to be the bulk of the presentation once we get past the intro part. So what are the key drivers? For those of you who are brand new to this market, what is multi-cloud networking? What is driving this market, the need for the market? First things, right? Customers, enterprises are moving their applications to cloud, nothing new there. Any enterprise that we talk to have presence in at least two regions. It could be a single cloud. Let's assume that they started with AWS, they have applications in multiple regions of AWS. Then some of the advanced enterprises, they're already running applications in multiple cloud. One thing that is great about the cloud providers, they have the tools, several tools as a release for specific problems. Take AWS, they have transit gateway for hub and spoke networking, and then they have private link for connectivity from one endpoint to another endpoint, and then they have cloud WAN, and they have verified access. You name it, there are a bunch of these tools. And then you replicate that for Azure, you replicate that for GCP. Of course, there's going to be inconsistency, and not everything is going to work the same way. So the abstraction layer, how do I actually put a single networking platform into any of this cloud and make them work the same way? So that is the primary need for this. When we work with enterprises, a couple of them mentioned that they have 3,000-4,000 VNets in Azure, 2,000-3,000 VPCs in AWS, and some growing in GCP as well. For them, just to kind of keep the lights on and make everything work together is the biggest problem they're facing. So that's the number one need. Some customers that were early to cloud in 2017, 2018, they tried to replicate the data center model in the cloud, right? If you really look at some of the topologies out there, they're also called multi-cloud networking, but their model requires putting virtual appliances in each of the VPC. You actually build a hub and spoke topology by dropping appliances inside VPC and then building IPsec tunnels, running BGP, things that you used to do in the data center. They tried to replicate that. That was okay in the early phases of cloud. Now think about what is the reality, right? There are PaaS applications, right? You have different types of connectivity models. You need to kind of make it work. And there are cloud native tools you have to leverage as well. This model is falling flat, and that is another driver for a modern multi-cloud networking solution. The third driver is app diversity. Anytime that we work with enterprises, they start, here are my applications that are running inside VPCs and virtual machines, the VMs, EC2 instances, you name them. And the modern set of applications, that could be around your Kubernetes and microservices. New applications are always developed on this modern framework. There's a set of applications like that, service mesh, you name it. Then comes PaaS services, customers leveraging the Redshifts and Google Vertex AI. So these are just PaaS services, couple of APIs they want to leverage. And then you think of a single application that needs to make it work. You start from a web front end in GCP, and then you're kind of going to a database, let's say in Azure, and then you're for AI, let's say you're leveraging a GCP, and some are still in the data center. So how do you kind of make all this work? Where a single networking stack should work for all types of applications, a TCP layer, HTTP layer, or even IP layer, and so on. That's another thing. And nobody wants to kind of go to the older model of configuring network appliances and kind of managing the old framework, right? It's all about net DevOps, GitOps. How do I ensure that just like how my app stack is kind of getting deployed, kind of in a CI/CD framework, how do I follow the same model for my network stack as well? Unless your networking stack is modern, can follow all the principles, you just can't do it. So this is another driver. When we work with enterprises, we'll show that in demo as well. How do I kind of run my entire network stack in a CI/CD framework? Lastly, cost. Cannot forget about cost in this current climate. This is just an example from a single topology of your hosting. This is just an AWS example. You could replicate this for Azure or GCP. A single transaction flowing through for a single GB, just network processing costs, right? Multiple types of load balancers. You have transit gateway, you have DX gateway, and then just the same flow, a single GB of traffic flowing through multiple services. Here's 8 cents for that. Here is 7 cents for that. Here's 3 cents for that. You add up to understand how much am I paying for a single GB of your data processing charges. That just adds up. And we did this analysis with our customers, just looking at their cloud bill as well, 17% on average just for networking charges. If somebody is paying 10 million a month, very large enterprise, just as the cloud bill, 1.7 million is just for networking charges. And they don't realize this until they kind of go deeper to figure out that where is this coming from? Who's consuming all this bandwidth? And why am I paying this processing charges, one for the firewalling, one for NATing, and one for routing, just back and forth and just processing charges? There has to be a better way to solve this, and we'll talk about how we solve this in our framework. So these are the top 5 drivers that drive the need for multi-cloud networking. Now we're going to introduce this term throughout the presentation called full stack cloud networking. Full stack could mean different things in different markets. So I'm going to explain what that really means in our terminology using a real life customer example, right? So all those drivers that I mentioned, let's start with the customer journey here. Think of a customer, simple customer. They said, hey, I'm moving to cloud. It could be circa 2018, 2019. I have a few VPCs I have to interconnect. That's how every single networking problem starts in the cloud. Many of you are nodding. Yeah, that's exactly it. They start with, okay, I have transit gateway, I have Azure VWAN, I can attach my VPCs and VNets, they're happily talking. That's just a starting point of it. Then comes the real enterprise use cases. Oh, by the way, these VPCs have overlapping IP addresses. I need to segment them for HIPAA compliance. I need to segment them for, let's say, PCI compliance, and they should never talk to each other. Or I want to segment them by staging, dev, production, and so on. What is the best way to segment them in the cloud? I don't want to go configure SG-ACL rules and network group ACL rules. Is there a better way for that? By the way, my security team is saying for compliance reasons, when VPC1 talks to VPC2, they have to always go through a firewall. Or when my data center traffic is coming back to the cloud or vice versa, they have to go through a firewall. What is the best way for me to insert a firewall in the path? And egress control. These machines, virtual machines running in the cloud, they have to go talk to gitlab.com or they have to go download Windows updates, whatever it is. I want to provide secure internet access for all of my cloud servers. And I just want to make sure that they are the only services they're talking. They're not talking to some random websites. How do I kind of block that? I don't want to kind of muck around with manual rules. That's the egress control part. And multi-account sharing. I may have a single transit gateway, but I have VPCs running in multiple accounts. How do I securely share these shared services, shared firewall services? Slowly, what started as a simple VPC to VPC network problem that some developer is, DevOps team is doing by themselves, is getting upgraded into an enterprise grade problem. And a network team comes in, they're trying to figure out how do I do this. That's a typical journey. Then take it one step further. It's just not a single region problem. I need to kind of go to a multi-region problem. I have apps in the East Coast and apps in the West Coast of US. I have to make them talk. Or I have apps for GDPR reasons I'm kind of putting inside Germany or anywhere in the EU. So this is starting to be a multi-region problem in a single cloud. One step further, they're much more mature in cloud. Now they're starting to talk about a multiple cloud. How do I interconnect my Azure regions back into AWS regions? Okay, do I use the cloud backbone? Or should I kind of get some private underlay circuits? And how do I manage all of them? How do I ensure that the routing works across all these underlay connectivity the same way? I can write policies around that. So it's kind of upgrade to a cross-region, cross-cloud problem. Still, we are talking only about layer 3 connectivity, right? Just IP layer connectivity, IP layer security, firewall insertion, and so on. This is the point where many enterprises are kind of, it's a big realization for them when their app developers come in and say that it is just not about this IP connectivity. I have all these applications, which I mentioned, PaaS apps. I'm maybe using Snowflake that is hosted by Snowflake, but in my own VPC or a managed VPC. And I'm leveraging this AI services, data lake services. How do I make them all talk to each other? Typically, they cobble together a bunch of proxies. Say, here is a L4 TCP proxy, here is a layer 7 proxy. Why don't we provide endpoint to endpoint connectivity? This API endpoint can go talk to the other API endpoint, so on and so forth. This becomes an extremely complex problem now. What started as a simple VPC connectivity. And when we walk into a lot of enterprises, this is the challenge they're facing. Now the problem is handed off to the network team, and they are trying to figure out what was the brownfield setup? What was the history when it started as a simple VPC connectivity problem, has kind of improved into this state, right? How do they go fix it? So that is where the full stack comes in. The story of when Prosimo demo, you'll see that it's all about the full stack from underlay connectivity to layer 3 overlay, all the way up to layer 4 and layer 7. This is exactly what we really want to provide. Any application type, whether it's L3, L4, L7, any types of application, PaaS or homegrown applications and so on. Doesn't matter what the connectivity model is. If they already have a transit gateway, it's our responsibility to kind of use that as a brownfield setup and make it work. Kind of leverage all the cloud native principles and make it work. Do they still have to tunnel to a B2B partner? Can we support tunneling? Yes. Can we support private link, which is an endpoint connectivity? Any application type, any connectivity, any cloud, and this has to be fully running in customers' own control. That's one key difference. When we work with these large enterprises, they're very, very clear about, hey, to make my cloud applications talk to each other, I don't want yet another middle mile provider. There's a concept of middle mile NAS, network as a service, where hey, here is a couple of these VPCs to make them talk. I'm going to bring my own cloud in the mix. Why don't you attach to my cloud? I'll make them talk. So that's not a model large enterprises want to go with. So I want the entire network stack to be running in my own control, my own administrative control. That way I can figure out the certificates and visibility, who has control. I want to own all of that. And lastly, who is the end consumer for all that? Let's say I go build this, the full stack cloud network in Prosimo. The end consumers are developers. They really want to move fast, right? We have enterprises that have 10,000 developers developing homegrown applications, right? Multiple thousands of VPCs. When I'm a developer and I'm ready with my application service, I should have a way to self-onboard the application. We're going to show a demo of that as well. Simply say that, hey, here is my application. It works on TCP layer. It asks to be consumed by XYZ services sitting in Azure. By the way, I have to go consume this AI service, Vertex AI in GCP, for example. And all these services have to be monitored by Prometheus service, which is a common stack. As a developer, I know this requirement. I know this policy. I want to stay within my guardrail. But can I go do it myself? I don't want to open a ticket and wait for somebody to take care of this requirement, so I can move fast. At the end of the day, our end goal is to truly make cloud networking a self-service option for anybody, all the abstraction layers built in. So that's what we're going to focus on. So that is the goal. On the business side, let's say we have this excellent technology. What is it enabling? For those business audience that are listening in, figuring out, hey, why should I need a platform like this? These are the key outcomes that enterprises are trying to unlock. First one is, how do I accelerate my cloud migration? I've been at it for 5 years, 7 years. I'm running into more and more complexities, right? Networking is slowing me down. I didn't realize the enormity of the problem. Now I do. But how do I kind of make sure that networking becomes an enabler and it doesn't slow me down? So accelerated cloud migration is the number one reason. And I always want to stay compliant, whether with the right level of segmentation, across cloud, across regions, and making sure that there's always firewall in the path for wherever firewall is needed in the path. There's so many compliance requirements that come in for network audience. How do I ensure that I can make it simpler for anybody, even a developer, to kind of make it work with compliance? M&A, I know it is not a kind of day in, day out problem, but when we work with large enterprises, we work with a company that acquired 3 companies every quarter. So this is the reality of a network audience, enterprise network audience, where they could be in any cloud. They might be using any type of brownfield connectivity model, but their job is to ensure that they can integrate that new cloud-based applications into their own homegrown applications, right? And that has to be done in like 2 weeks, 3 weeks turnaround. So accelerating this M&As is a key problem for cloud. And modernized infrastructure is a no-brainer. Nobody wants to kind of maintain this older appliances in the cloud. So they want to kind of, just like how they're doing app modernization with Kubernetes and microservices, serverless, and so on, the network stack has to be modern enough to keep up. So that's the infra modernization. Developer velocity I touched on. There are goals now for centralized cloud platform team. The goal is to ensure that it used to take 3 weeks for developers to turn around and make an application live. Can we cut that down to 3 hours, right? These are measured goals for developer velocity, and we are making it real. And last one, I'll hand off to the demo team now, is the B2B cloud. Business partner connectivity. We work with a big bank, and they have to interconnect their application with 3,000 other business partners, right? It could be clearing houses, it could be kind of financial marketplaces. They really have to go connect to 3,000 other places, and they're all running in the cloud. So everybody has moved to cloud. When business partner connectivity comes in, it is becoming kind of a mini marketplace of connectivity. Hey, how are you looking to connect to me? How do you use transit gateway? How do you use private link? Here is my application. Go to this portal and select the catalog. How do you want to connect to me? It used to take like, let me ship a router, and you have to kind of follow the IPsec profile and connect back to me. Those days are gone. It's about following a catalog and enabling business partners to connect right away, right? That's another outcome that enterprises are looking to drive. So with that context set, we're going to jump straight into demos and deep dives. We'll take one challenge at a time. We have 5 or 6 challenges. We don't have time to highlight all of these. We'll make it real, take one challenge at a time, go deeper, and show it in action. And any questions before I hand off to my technical counterparts?
Great start.
Was it a good overview, guys? I put the right pin on the right map, right place. Good. Okay.
Yep.
Your description of, I'll say, I think you said middle mile. That was an interesting phrase, and the idea that basically data goes out, comes back to us, then goes back out to somebody else. And that's an interesting. We'll see it in the demo. We don't have to dive deep on the concept, but I like this idea of you think you're securing it, but the entire life cycle of that data is not secure.
Exactly.
Yeah.
It's one of the reasons why we provide the stack. We're a technology provider. We don't ask customers to route traffic to our cloud. In fact, we don't even have a cloud. We go deploy our stack in customers' own accounts.